Hi, in this video, we're going to be looking at a important aspect in C programming known as bit masking. Okay, so what is bit masking? Okay, so let's say I have a 16-bit variable here. Okay, let's call this num. Okay, and let me draw out the 16 bits over here. Okay, and I'm going to break them out into groups of 4. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. All right. So let's assume that for this variable num, I'm interested in bit 5. Okay, so I want to know whether bit 5 is set or clear. And what I need to do is I need to perform a AND operation, okay, with a mask where this particular bit 5 is set to 1 and everything else is set to 0 before and after. Okay, so let's look at what is this AND operation that I'm talking about. Okay, so AND or the ampersand AND over here. So in terms of digital logic, an AND gate looks like this, where if I have two variables a, b, okay, and output x, let me draw the truth table here. So in an AND gate, as long as any input is 0, okay, the output will be 0. When both inputs are 1 or all inputs are 1, then only the output will be 1. So in this example, if my bit 5 happens to be a 1, then 1 AND with a 1 will give me a result of 1. Okay, but if my bit 5, okay, happens to be 0, okay, that means if this happens to be 0, 0 AND with a 1 will give me a 0. All right, so that is basically what we need to do. All right, okay, so before we go into the coding, we also need to understand that in many cases, all right, the checking of whether a particular bit is set or clear might be applied to a wide range of variables or registers, and you may also need to check different bits for different registers. Okay, so in some cases it's bit 5, some cases bit 7, bit 10, and so on. Okay, so what we're going to do is we're going to explore how we can write the code efficiently, all right, to make sure that the uh, code can be reused easily for any bit position that you want to check. All right, so let's look at the code. Okay, so the code is here. All right, and what you see here is I have defined a mask, okay, where the mask is x with one shift left to the value specified by x. Now, what is this doing? Okay, what is this doing? Okay, now let me come back to the OneNote here to give you the idea of how this works. Okay, so when I say mask, okay, x, which is 1 shift left x, all right, so when I put in a value of, let's say, 5, so it will be 1 shift left 5. So 1 shift left 5 means if I look at the bit positions, all right, so let me put the bit position 1, 0, 1, 2, 3, 4, 5, 6, and so on. If my current one is here and I shift left by 5, so it will be 1, 2, 3, 4, 5. So the 1 will come here. All right, so you can see that it moves the particular 1 to the correct bit position. All right, and this makes my life easier because I don't need to worry about manually thinking where to place the 1. All right, it automatically takes care of the correct positioning for the 1. Okay, now coming back to the code, okay, we can see that I create this mask definition and I want to check for bit 5. All right, and in this case all I need to do is perform the AND operation with whatever variable that I have, and I do it with the mask and I check whether the bit is set or clear. Okay, so I'm going to test with two numbers, 9, all right, and another number, 33. So when I use number 9 and if I run the code, you can see the bit 5 is clear, and if I change the number here to 33 and if I run, you can see it is set. All right, so how do I check whether this is correct? Okay, so this comes back to the binary representation of numbers. So 9, okay, is 1001. All right, so all the other bits are 0. Okay, so in terms of the bit position is 0, 1, 2, 3, 4, 5. So you can see that bit position 5, it is 0. Okay, now at 33, what do I get? So it is a value of 1, 0, 0, 0, 0, 1. Okay, 0, 0. So for 33, the bit 5 position is set. All right, so if you're not very familiar with binary, okay, we say that the bit 0 is 2 to the power of 0, this is 2 to the power of 1, and so on. So this will be 2 to the power of 5. So 2 to the power of 5 is 32, this is 1, so that will give me 33. Okay, so that is how we are able to check that the code given here is actually correct. Okay, so I hope this gives you a clear idea how we can write some code to do the shifting, okay, and the masking to know whether any particular bit is set or clear. Thank you for watching. I'll see you in my next video. Bye.